Here we have the completed ventilator board, and we'll analyze it in Hyperlinks DRC. Here's that identical board. So Hyperlinks DRC is a tool that provides automated checks that can identify root causes of common electrical problems. Oftentimes those problems are hard to deduct from just running a transient analysis. If you were to see a waveform, you may not be able to tell what's causing a reflection. But Hyperlinks DRC is a tool that will allow you to spot those problems. And the strength in Hyperlinks DRC, it automates these mundane tasks. You may have thousands of areas of the board that you need to look at, and Hyperlinks DRC can spot those to you and give them to you in a report in less than a minute. So what Hyperlinks DRC is, it has 80 DRC checks. Some very popular ones that we'll show today are nets crossing gaps, and also a stitching via check. This nets crossing gaps check is popular where if you have a net and it goes over a gap, you may have a change in the characteristic impedance, and that will cause a reflection on that net. And also the current will need to find a return path. And if several nets are sharing a return path, you may get simultaneous switching noise, which will degrade signal performance. So each rule is like a function. It will have input arguments, which are something called an object list. So this one here is nets crossing gaps on the data. So we can take a look at this data object list, which has all the data lines inside of it. And then this rule will also have certain parameters or arguments that you can apply to the rule to tell you how strict you'd like that rule to be. Would you like it to over-report every small violation or only go for the worst violations? So if we were to run this rule, we just execute, and it will crawl through the design. It found 38 violations, so let's take a look. So here we have a net crossing a split. We may want to take a look at that. Another net crossing a split. Now if these three nets are all crossing the split, they'll probably share a return path, and that's where that simultaneous switching noise can become problematic. Another quick check we can do is the stitching via check, or stitching component check. When a signal is referenced off a certain plane, let's say you have some signal on layer 1 and it's referenced to ground on layer 2, and you go through a via, and out of that via, let's say the signal goes out layer 6, and now you reference that ground plane on layer 5. Is there a stitching via nearby so you can actually have a close return path, or will the return path be capacitively coupled between those two ground planes? If they're different planes, is there a stitching capacitor nearby? This check will look for answers to both of those questions. And so we can run this stitching via check. This one's on the address object list, where I have a group of address nets, and the input arguments here are decoupling distance, stitching via distance. It will search within a certain radius to find one. So let's go ahead and run that check. So here we have a net, and it's saying it's referenced off ground on layer 2, and it goes to the via, and it's referenced now on V24 on layer 5. And within this certain radius, it's a little bit hard to see there, there's no stitching via or stitching component nearby. And so that's an area that the designer may want to investigate further. It'd be hard to see that in the simulation. And so that's the strength of Hyperlinks DRC. It automates these simple checks, and it also provides them in a clear, easy-to-read spreadsheet. Here we have another one of, we have this one is referencing ground on layer 2, and out of that via it now reference 5 volts. So you may have a lot of noise when the return current is trying to find its way to through those two planes in this vicinity. And that could affect other signals nearby, all of these vias nearby as well. So that's a brief introduction to the post layout tool Hyperlinks DRC. It actually can be run inside the Expedition layout client if you'd like, and I'll show you a method similar to that in the Valor tool later on in this webinar.